Hey Geometries, this is Mr. Bloom, once again with lesson 7.2, day 2, similar polygons. Our objectives today, students will be able to identify and apply similar polygons. Same objective as day 1. Wonder if they're connected. Let's go find out, okay? So we are using similar polygons. Yesterday the emphasis was corresponding sides in an extended proportion. So let's do that. Let's set up an extended proportion using our corresponding sides. Where do I find them? Where would I find corresponding sides here? Hey, look, I have a similarity statement. I have segment AB is similar and corresponding to EF. And segment BC is similar and corresponding to FG. Segment CD is similar and corresponds to GD. And segment AD, I haven't done that one yet. AD is similar and corresponds with segment ED. Now, this is the extended proportion for similar figures. And I'm telling you right now, because of this tilde, those are similar figures, and so these are proportional, and we can set up a relationship. But first, I got to find out which side's which. So if I look at AB, I have the value of 5. EF, I have Y. Now, BC, I have 7.5. And FG, I have X. Boy, those aren't helpful because there are two different variables and I can't solve for two different variables like this. Let's go on and see if we get more information. CD, CD, I have no idea what that one is. DG, no idea what that one is. AD, AD, that's value is 9. And DE value is 6. Whoa, this is pretty darn cool. I'm going to use this relationship. And either one of these two, I can use the 7.5 over X, or I could use the 5 over Y. All I have to do is use one of these variable related relationships, 5 over Y or 7.5 over X, with the red 9 over 6. Now, they ask me to find X. What is the value of X? So I am actually going to use the value of X, and let's make that green so it makes a lot more sense here. Hey, look, now that's green, maybe. Let's see if we can do that better. Hey, look, now that's green, boys and girls. So here's how we're going to find X. I've got 7.5 to X is equal to 9 over 6. Are you okay with how I related this? Remember, this was set up because of corresponding side measures. Although CD and GD has no information to help me here, all of these are equal to one another, so I can use this in a proportion and cross product and multiply them together. So I can go 7.5 times 6. I grab my trusty steed of a calculator. 7.5 times 6, and I find out that's 45. So that is going to be 45 is equal to 9x. I divide by 9 and find out that 5 is x. Well, they asked me what the value of x is. Well, it's 5. So I know this is 5. Now, my next question was, hey, what's y? I wonder if I found enough information to help me find y. Why, by Jove, I did. Check it out. I have enough information to have a variable of y in here. And guess what? I'm still going to use 9 and 6. And go for it. Find y. So 5 times 6 is 30. 9 times y is 9y. Dividing by 9, I get 30 ninths. Now, remember, this isn't that bad. Both of them have 3 in common. So I just divide 3 out, and I have 10 thirds is equal to y. Now, some of you went, well, Mr. Bloom, I got 3.33333. Well, you did, but I'm just using that fraction of 10 thirds, and it's totally fine. 3.3333333 is also a value for y as well. It's the same. Okay, I hope things are going well with that, and we just set up corresponding sides. Corresponding sides is the theme. Once I know all the angles are congruent, corresponding sides are proportional when they are similar figures. And they gave us the similarity statement here. Check it out. This is the similarity statement right here. That was gold. Okay. Now, using similarity. We're using similarity. Your class is making a poster. The original poster is 5 by 7 inches. However, you want to make the poster bigger when you hang it up. The original poster and final poster are similar if one dimension of the final poster is 35 inches. What are the possible dimensions of the final poster? Possible dimensions. See, they're even saying that 35, if this is my possible final poster, okay, all right. Now, this is my possible final poster. Let's clone that just for fun. And they're giving me two possible things. They're saying either this is 35 and this is X, or they're saying this is Y and this is 35. Okay, that's what they're saying here. If one dimension of the final poster is 35, what are the possible dimensions of the final posters? One of them is 35. Okay, but the original was 5 by 7. So if I start with a 5 by 7, okay, if I have one dimension, 35 over X, let's solve for that. I go 5 times X equals 7 times 35. Now when I divide by 5, and I could use my calculator, but I know 35 divided by 5, 7. 7 times 7 is 49. And I have some people going, what? How did he do that? So we're going to talk about that real quick. All I did was go 35 divided by 5 times 7 equals, hey, look, it's 49. Crazy. Now, that is my first possibility. Okay, so X could be, remember, if I'm dealing with my little card, 5 by 7, X could be equal to 49. Now, the other possibility is if I had a 5 by 7 and, I had Y over 35. Well, that's the other possible way to have my dimensions. So I've got to keep this in mind when I'm doing this problem. And I cross multiply. I have 5 times 35 is equal to 7 times Y. I divide by 7, and I find that Y is 25. So I could find out that Y is 25. So these are my two possible ways I could orient my poster that's originally 5 by 7. I could make a 35 by 49 or a 25 by 35 depending on the material I have available for me. So these are my two possibles. Okay, and just to make sure you know, I have two possible dimensions. Either 35 by 49, and this is in inches. And by the way, let's show you the shortcut for inches. Inches is a double hit. Or I have 25 inches by 35 inches. Okay? So those are my two possible ways to do my poster dimensions. Now, let's talk about scale drawings. If I have a scale drawing, in a scale drawing, all lengths are proportional to their corresponding actual lengths. The scale is the ratio that compares each length in the scale drawing to the actual length. The lengths used in a scale can be in different units. For example, a scale might be written as 1 centimeter to 50 kilometers, or 1 inch is equal to 100 miles, or 1 inch is to 10 feet. So we got to be able to, adjust based on how they tell us the scale. You can use proportions to find the actual dimensions represented in a scale drawing. So let's talk about proportions, and we will even bring in some information that you've used in science. Okay, first of all, the diagram shows a scale drawing of the Golden Gate Bridge in San Francisco. The distance between the towers is the main span. What is the actual length of the main span of the bridge? Well, this distance here is actually provided to you here. The length of the main span is 6.4 centimeters, okay? And let's make that a little bit bigger. So we have that out. There we go. So the main span is 6.4. So from this column to this column in our sketch is 6.4 centimeters. Now, in our sketch, so we know we have model. Someone's got to be able to write model correctly. We have model and we have real. And they're saying that our 1 centimeter is 200 meters. Okay, so we know that our model is 6.4 centimeters here, or our sketch, and we're finding how many meters. So we can cross multiply and find out, okay, we've got X centimeters, or just X is equal to 200 meters, okay, times 6.4 centimeters. Okay, so 200 times 6.4, and that's going to give us our total meters, because these are centimeters and I'm looking for meters down here. So I'm looking for the value of X. So I take my trusty steed of a calculator, I take it out of the barn, and I go, okay, we got 200 times 6.4, and that is going to be 1,280. So I have 1,280 meters between the pillars, or the main span, is 1,280 meters. Okay, that's the length of main span. Now, there are other ways to do these problems sometimes. And I want you guys to realize that you guys went through science, and this is a conversion factor. I know that 6.4 centimeters is what I was provided. And when I'm given a conversion factor, and I want my answer really in meters, real life, and maybe because I'm doing this in a different color, a different problem, we should do it in a different color. This is a different way. If I take and go, well, I know it's 200 meters for every 1 centimeter, and my centimeters are crossed out, I then multiply by 200 by 6.4, and I still come up with 1,280 meters for the length of main span. I always have students go, well, I did it differently. Yeah, you kind of can, but really comes down to the same relationship. Okay, this is stoichiometry in blue, this is science, and this is us using ratios in the green. Okay, so keep that in mind. Different methods, same answer, but if you've got questions on either one of them, let's talk. Okay, use the similarity statement to finish the statements below. Hey, look, it's a similarity statement. What do you remember about similarity statements? Oh yeah, order matters. That's all I'm going to tell you. Tell me which angle. Tell me which side. Go. Okay, so JD, woo, D, W, H, angle H. They're equal. Okay, they're congruent and therefore equal. RT, so I got RT, YX. They got WX on the bottom. Well, WX first and last. JT, JT. Hopefully those went well for you. Order matters. Okay? And our summary today. Objectives. Our students will be able to identify and apply similar polygons. Write a couple sentences about something that you learned about the learning objective today. Okay? And then rate yourself on a scale of 1 to 4. Now, again, at the end of each section, you should turn to the inside cover of your notes and mark off on the Chapter 7 formal scale what things you learned, what things you know about, and and start kind of figuring out what things are yet to come. Precursor of things yet to come are listed here, because once you check off the things you know, the things we don't know are yet to come. Okay, so again, as always, if you have questions, please seek out your local geometry instructor and ask it. Okay, I hope things are going well, and I hope these things are being understood. And again, I'm Mr. Bloom, and you're not.